Millions of years ago, nature structured thousands of hydrogen and carbon combinations to create crude oil. Modern man learned how to fraction these hydrocarbons into aromatics, naphthenes, and paraffins, and to further refine them into fuels and lubricating oils. These lubricating oils, so essential to internal combustion engines, are frequently misunderstood and misused. Yet their role is vital to engine power, performance, and reliability. With the low-powered engines of yesteryear, all we asked of an engine oil was lubrication to reduce friction and wear. But today's high-powered engines operate under heavier loads, faster speeds, at higher compression and temperatures, and moving parts are fit to much closer tolerances. We now know that what we traditionally refer to as lubricating oil actually serves four purposes: to lubricate, cool, seal, and clean. Anytime there is metal-to-metal contact between moving parts, scuffing, scoring, or wear is bound to occur. Wear also results from acid, corrosion, rusting, and abrasion caused by contaminants. So oil is required for lubrication. Engine oil must also help cool the engine. Heat is transferred through an oil film to the cylinder walls and cooling system. Heat is carried from the underside of the piston crown and skirt to the engine crankcase. Bearing temperatures are minimized by the oil to prevent failures. Piston rings alone cannot create a seal between the cylinder wall and the piston against the tremendous pressures of combustion. They depend on an oil film to create a seal, thus minimizing blow-by. During engine operation, deposits form on the piston and rings. These deposits include unburned and partially burned fuel, corrosive acids, dust and dirt, and water. The oil must remove these to prevent ring sticking and excessive wear. So oil is used for cleaning, lubricating, cooling, sealing, and cleaning. The four functions which engine oils must accomplish. Each is equally important. If any one of these functions is impaired, so are the other three, because these functions are interrelated. When the oil is accomplishing its four purposes equally, it's in balance. None of the functions has been stressed at the expense of another. Engine oil ratings and classifications are sometimes misunderstood, although they're of vital importance to the user. Best known, perhaps, is the Society of Automotive Engineers, or SAE classification, which measures the oil's viscosity, that is, its fluidity at a given temperature. Various additives are used to create multi-viscosity oils, which can be very useful during times of rapid and extreme temperature changes. Oil is further rated by API and military specifications. But the best way to decide what oil to use is to consult the operator's manual, where SAE weight and other ratings are clearly spelled out. Above all, buy quality. There is no such thing as cheap oil. The lower its quality, the more it costs in the long run. Oil contamination is inevitable. From the time new oil is poured in the crankcase, it immediately starts to become contaminated. The important thing is to drain the oil before it becomes saturated with contaminants and ceases to do its job. Carbon deposits form rapidly in the combustion chamber and find their way into the oil through blow-by, as well as through the oil's cleansing of the piston, land, and ring grooves. Water produced by combustion and condensation is a constant menace to efficient lubrication. Fuel dilution thins the oil. When water combines with the acidic content of partially burned fuel, it corrodes engine parts and enters the oil. The total result, sludge. It will foul piston rings, restrict and close oil passages, and ultimately lead to failure of the lubrication system and the engine. Sludge is an everyday occurrence in an improperly maintained crankcase. The use of inferior oils and the malfunction of fuel, air, and cooling systems also contribute to sludge formation. Overheating and overloading are also great sludge producers, and thus the obvious need to keep the crankcase oil maintained. Modern engines feature a full-flow pressurized oil system. It consists of the oil pan, the oil pump, the oil filter, and appropriate passages to direct oil to all moving parts. Some engines are also equipped with a crankcase oil cooler. Preventive maintenance of the lubrication system starts with selecting the best quality of oil available for the engine application, using the viscosity recommended in the operator's manual, constantly observing crankcase oil condition and maintaining the proper oil level. Does an engine burn oil? Most certainly. The piston rings meter a certain quantity of oil on the liner to properly lubricate pistons, rings, and liners. Normal temperatures within the engine result in oxidation of some of this oil. Remember the fuel, water, and acids that seep into the oil? They can replace the volume of oil that's been oxidized, thus causing the dipstick to read full and encouraging a false sense of security. The oil filter should be changed on a scheduled basis, at least as often as recommended in the operator's manual, more often if conditions demand. Remember, the operator's manual only states the maximum time the oil and filter should be used. Good judgment tells how often they should be serviced. Many full-flow filters have a special built-in bypass valve. When replacement is necessary, use only a genuine duplicate of the original filter. A quality filter has tremendous filtering capacity. Remember, the filter removes only solid contaminants from the oil. Liquid contaminants, such as water, acids, and coolants, will pass through the filter. Oil is formulated to keep them in solution rather than forming into a harmful sludge. So the color of the oil doesn't determine the need for change. If the oil is really doing its job of cleaning and keeping contaminants in suspension, the oil will appear to be dirty even after a few hours' use. This is properly formulated oil doing its job. Despite all the radio and television commercials to the contrary, don't use additives or dopes in the engine oil. Under the most ideal conditions, they might have a slight tendency to do the things claimed for them. But remember that the best oils are already balanced. They don't require any added phenomenal property. It is possible to upset the balance of the best oil by adding an additive. The best practice is to invest in quality oil and forget the dope. A modern top quality oil with maximum metal wetting ability and detergent can safely be used to help clean up dirty engines. When adding such an oil to an exceptionally dirty engine, remember that the carbon, sludge, and other contaminants will probably overload the oil at first. This accumulation of filth will be rapid and must be drained from the engine when the oil shows signs of thickening. Don't expect to perform the first oil change in the maximum interval specified in the operator's manual. Observe the dipstick closely until the engine is clean. Many factors affect oil consumption. For instance, on naturally aspirated engines, a restricted air filter creates a higher negative pressure in the intake manifold. So the pistons draw oil from the engine crankcase in an attempt to pull in more air during the intake stroke. Worn valve guides also allow oil to be pulled into the cylinder. The piston rings are designed to distribute oil on the surface of the cylinder liner in exact amounts. Worn piston rings mean that more oil gets metered to the cylinder walls. Using the wrong oil, that is, an oil of the wrong viscosity or lacking the needed additives, can cause sticking rings. A sure way to spend lots of money is to buy cheap oil. Always allow the engine to sit a while before checking the dipstick for oil level. This permits the oil to drain into the crankcase. Since oil expands with heat, the best practice for checking oil level is to do it when the engine oil is at normal operating temperature and the engine has been shut down about 15 minutes. Avoid overfilling the crankcase. Oil should operate at temperatures above 150 degrees Fahrenheit. Cold engine operation permits excessive fuel dilution and acid formation. Preventive maintenance of the crankcase costs so little. The best oil, changed as frequently as recommended, more frequently if conditions require, and scheduled changing of the correct oil filter are the best investment you can make to avoid downtime and costly repair. With the fantastic productivity of today's machines, we can't afford lost job performance, let alone the costs incurred by labor and parts replacement. Lubricate, cool, seal, and clean. Those are the vital jobs performed by today's oil for today's modern engines. We go a long way for the fuels we burn in today's modern engines. Miles below ground, often miles below the sea as well. Of course, engines can't burn the crude in its raw form, so we refine it. And the better the refinery, the better job it does of removing the impurities that would otherwise contaminate our engines, especially dirt, water, and paraffin waxes. Now the fuel moves to regional storage and eventually the local distributor. From the refinery to on-site storage facilities, the quality of the fuel used depends on the quality of those who refined, transported, and stored it. This is what you buy in a brand name. It's the reason why it's so important to select a reputable source for all fuel requirements. When it comes to preventive maintenance of an engine's fuel system, cleanliness is the name of the game and can't be stressed too much. Cleanliness starts at the refinery, and once the fuel has been delivered, it's entirely up to you to maintain it. Whether we're talking diesel, gasoline, or LPG, all fuels have the same job to do: to ignite, produce heat, and by expanding gases, to generate power. Contaminants in the fuel can reduce that power considerably and frequently cause costly engine damage as well. When reference is made to a specific gasoline's octane rating, it is simply a measurement of that gasoline's ability to resist knocking. By using additives and through modern refining techniques, the octane rating is controlled to permit the gasoline to burn slowly and evenly in a high compression engine. A gasoline with too low an octane rating for the engine will ignite in an explosive manner, producing a damaging knock. The operator's manual specifies the minimum octane rating permissible. In almost all cases, this rating permits the use of regular grade fuel. While premium grade, that is higher octane fuels, are usable, they offer no advantage unless the manual specifies their use. In the case of diesel fuel, just the opposite property is desired. The cetane number of a specific diesel fuel refers to its ability to produce fast, spontaneous combustion. This combustion is controlled by the rate of fuel injection. But a diesel fuel cetane number is only one of many properties to be considered. Two major grade classifications are most often recommended for high-speed diesels. They are grades 1D and 2D. The owner's manual specifies their use and should be followed accordingly. In any case, never burn furnace fuel in a high-speed diesel engine. Furnace oil contains more of the heavy cracked distillates, such as wax. It can rapidly clog the fuel system, and in cold weather, it thickens and may not flow through the system, as shown here on the left. It can make engine starting virtually impossible. On the right, diesel fuel flows freely. Remember, refineries do not attempt to supply dealers with a fuel oil that's suitable for both diesel engines and heating a home. Once you've selected the right fuel from a reputable dealer, it's important to maintain that quality. Keep the fuel free of harmful contaminants and condensation when the fuel is being pumped into an on-site storage tank. If there is any water present, the water mixes with fuel in small droplets. The tank is tilted slightly to collect water at the low end and away from the hose. This water will settle to the bottom in about 24 hours. The water should be drained at the rear of the tank periodically. The hose should have a filter to further separate water and other impurities. As you can see in this demonstration, water settles out of gasoline far more rapidly than it does from diesel fuel. Therefore, allow a newly delivered tank full of diesel fuel at least 24 hours for water to settle before using. The best practice is to use 2 storage tanks. Never store diesel fuel in a tank that has previously been used for gasoline storage. Over a period of time, various contaminants in gasoline, shown here in these vials, settle to the bottom and build up on the inside walls of the tank. Diesel fuel loosens this accumulation, which then floats in suspension. Diesel fuel also reacts with galvanized metal, so it shouldn't be stored in a galvanized tank, since the subsequent corrosion will clog the engine fuel system. Diesel and gasoline is stored and handled much the same. They're subject to heat absorption and evaporation losses. By storing in a light-colored tank that's well shaded and equipped with a pressure vacuum relief valve, evaporation losses can be drastically reduced. The filler hose nozzle should be properly cared for. Be sure the nozzle is clean. Before inserting the nozzle in the fuel tank, it's good practice to shoot a bit of fuel through the nozzle to flush water or any other contaminant from the nozzle. We strongly recommend a filter between the tank and the hose. And of course, store the nozzle downward with a cover on it when not in use. Here is one of the greatest potential sources of fuel contamination: the portable tank that is taken to the job site. Whatever its size, all the care exercised in on-site storage is wasted if the portable container is contaminated. Remember that the quality of the fuel in the engine supply tank is only as good as the cleanliness of that portable tank. LP gas must also be purchased from a reputable dealer to make sure that contamination in the storage tank is minimal. In addition to other contaminants, LPG contains propylene, a sticky substance that tends to gum up the engine fuel system. A fuel filter is located between the LPG engine supply tank and the converter. Should the filter become clogged, the restriction will cause the filter to accumulate frost with the engine running. A typical diesel engine fuel system has a fuel storage tank, a fuel transfer pump, a single or dual fuel filter, an injection pump, injection nozzles, and connecting lines. The transfer pump draws fuel from the engine supply tank. Whatever the tank capacity, size, and shape, it must be vented to allow air to enter and replace the fuel used. The filler cap should always be wiped clean of dust and dirt before removing it for refueling. The engine supply tank is equipped with a water drain. This drain should be checked periodically for water that might accumulate from condensation. Modern diesel engines have a fuel transfer pump, which supplies sufficient pressure to move the fuel through the filters. The pump usually has a hand primer lever for bleeding air from the system. This pump also contains a fuel strainer. Fuel filtration is very important in a diesel engine because injection parts are precision made to extremely fine tolerances. These precision parts must be protected from the most minute abrasives. In this dual series type filter, the fuel passes through a first stage element, then it passes through the second stage element. This element is designed to trap and reveal water that comes from poorly maintained fuel. There are other types of filters, such as these. The fuel from the filter moves under moderate pressure to the injection pump. They vary in makes and models, but their purpose is the same. Injection pressures will be as high as 5,000 to 10,000 psi at the time of injection. Spring pressure holds the injection nozzle closed until just the right instant, when the high pressure forces it open to inject the fuel. The timing of injection is extremely critical, just as the timing of a spark in a spark ignition engine. The diesel nozzle must inject the precise quantity of fuel in a spray or atomized form. Some injectors have a fuel filter built in, which can filter out foreign particles as small as 1 micron. Just for comparison, a particle 1 micron in size equals 1/100th of an average human hair. This suggests the fact that even extremely small impurities in diesel fuel can be very injurious to precision injection parts. Whenever diesel or gasoline-powered machines have been idle for any length of time, it's wise to check the fuel tank drain for water and sediment. If a gasoline engine is to be stored for a long period, drain the gasoline tank and carburetor. On the other hand, a diesel engine should be stored with the system full. Use this engine storage preservative and add to the diesel fuel system as directed. Always refuel the equipment at the end of the work period. This minimizes condensation in the tank, and it assures a full fuel tank at the start of the next work period. Of course, the fuel cap should be wiped clean, just like the fuel hose nozzle. Some fuel systems are equipped with a sediment bowl on the fuel pump. This bowl should be removed and cleaned periodically. Fuel filter elements should be replaced as specified in the operator's manual. Before removing the filter during service, clean the entire filter area of dust and grime. Otherwise, these impurities will be washed into the injection system, and severe damage could result. If you find that it's frequently necessary to change the fuel filter, don't blame the filter. The fact that it's loading up with impurities is proof that it's doing the job it was intended to do. As you can see, it has plenty of filter area to trap contaminants. So filters that clog too soon indicate that the fuel being supplied is contaminated. To eliminate contamination, clean the engine supply tank. Check and clean storage tanks as necessary. Also, check the fuel supplier. When the fuel filter is replaced, use a factory-authorized filter element. Will fits may appear to last longer, but in reality, they're seldom designed to remove as much contamination from the fuel. Eventual damage is the ultimate result. When the fuel filter is removed, or whenever the machine runs out of fuel, air should be bled from the fuel system. The operator's manual specifies this procedure. If the engine still misses after bleeding the filter and will not smooth out, the entire fuel system should be bled. Anytime you suspect problems in the injection system, be sure to have it inspected. Otherwise, the consequences can be drastic. For example, when contaminants enter the injection pump, They wear away the finely fitted parts and result in expensive damage. Clogged nozzles can create enough pressure to cause total pump failure. Also, they can have distorted spray patterns that spray first on cylinder liners and wash away lubrication. A distorted spray pattern can result in damage to the piston and rings. Careless fuel storage or negligence in replacing an inexpensive fuel filter can thus result in hundreds of dollars in repair costs, often thousands of dollars lost when downtime prevents a machine from performing when it's needed. Remember, when it comes to the fuel system of today's high-performance engines, the name of the game is cleanliness. That's the way to get all the power possible from every drop of fuel in today's high-performance engine.